I'm John Strum, and this is RealTalk MS. Happy New Year. It's January 3rd, and we have a lot to talk about. Every week on RealTalk MS, we look at some of the amazing research that's taking place around the world. This week, we're looking at how an international group of MS experts is proposing that research should be leveraged to improve your MS care. My guest today is Professor Tanja Kuhlmann, the lead author of a paper that's proposing a new framework for how we research MS, diagnose MS, and treat MS, even how we talk about MS. It's a fascinating proposal that's already creating important conversations in the MS research community. But before we get to my conversation with Professor Kuhlmann, there are a few other things that you should know about. Last week, the U.S. Food and Drug Administration approved Eubilateximab, an anti-CD20 or B-cell depleting disease-modifying therapy for multiple sclerosis. Eubilateximab will be marketed under the trade name Briumvi, and Briumvi was approved for treating clinically isolated syndrome, relapsing remitting MS, and active secondary progressive MS. Results of the Phase 3 clinical trial for Briumvi showed that, compared to Aubagio, Briumvi was more effective at reducing MS relapses and preventing new lesions among people living with relapsing remitting MS over a period of 96 weeks. Briumvi's manufacturer, TG Therapeutics, conducted two identical Phase 3 trials, enrolling 549 people in one trial and 545 people in the other identical trial. Both trials showed Briumvi to be twice as effective as Aubagio in preventing MS relapses. In one of the two trials, no evidence of disease activity was observed in 44.6% of the participants given Briumvi, compared to 15% of the participants given Aubagio. And in the other trial, no evidence of disease activity was observed in 43% of the participants given Briumvi, compared to 11.4% of the participants given Aubagio. Now, some of you may be saying to yourselves, aren't there already approved anti-CD20 therapies available to people living with MS? And the answer is yes. So why should there be one more? Well, I think we all know that people respond to the same MS medication differently. Perhaps this could be the high-efficacy therapy that some people respond to best. And the other differences between Briumvi and other anti-CD20 therapies are time and money. Ocrevus is an anti-CD20 therapy, and like Ocrevus, Briumvi is given every 6 months by infusion. However, Briumvi is formulated to be more potent, so while an Ocrevus infusion takes 2 or 3 hours, a Briumvi infusion takes just 1 hour. So Briumvi may be a therapy that fits better into someone's busy life. And when it comes to cost, insurers may appreciate that while so far no price has been announced for Briumvi, its cost is expected to be about $30,000 a year per patient, which is less than half the per patient cost of Ocrevus. I want to also point out that Kesimpta is another B-cell depleting monoclonal antibody, and Kesimpta is administered once a month at home using an auto-injector. So each of these three anti-CD20 disease-modifying therapies offer varying levels of convenience to the end user. You can expect to see Briumvi being made available sometime over the next 90 days, and if you'd like to review the Phase 3 clinical trial data for Briumvi, you'll find a link in today's show notes. Also last week, AB Science, a pharmaceutical company based in France, received approval from the U.S. Food and Drug Administration for its Phase 3 clinical trial of Mecitinib to treat primary progressive MS and non-active secondary progressive MS. Mecitinib is an oral medication that works by blocking an enzyme that's essential for the activity of innate immune cells, the cells which are thought to drive neuroinflammation and neurodegeneration in progressive MS. By suppressing these cells, Mecitinib is expected to slow disease progression in progressive forms of MS. And one of the benefits of Mecitinib is that it selectively targets these innate immune cells, leaving the rest of the immune system intact. The Phase 2 clinical trial for Mecitinib involved 656 participants and showed that compared to a placebo, 2 years of treatment with Mecitinib was effective at significantly slowing disability progression in adults with progressive forms of MS. And here's a fun fact. Mecitinib has actually been available in Europe since 2009, but not to humans. It's been marketed under the name Masivet, and it's used as a treatment for mast cell tumors in dogs. The Phase 3 Mecitinib study is recruiting 800 adults between the ages of 18 and 65 with primary progressive MS or non-active secondary progressive MS. Study participants must have an EDSS score between 3.0 and 6.0, which translates to moderate disability. And study participants must not have any T1 gadolinium-enhancing brain lesions on their MRI scan. A T1 gadolinium-enhancing lesion is an MS lesion with active inflammation. The 800 study participants will receive either Mecitinib or a placebo for up to 2 years, and the study will be carried out at 75 sites in Europe, the United States, Canada, Israel, and South Africa. We've been following Mecitinib on this podcast since September 2020, when AB Science first reported their encouraging Phase 2 clinical trial results, and you can be sure that we'll keep you updated as the Phase 3 study moves forward. If you'd like to learn more about Mecitinib or inquire about participating in the upcoming Phase 3 clinical trial, you'll find a link to the AB Science website in today's show notes. We first introduced you to Therapeutics in 2001, when the life sciences company came out of about 2.5 years of stealth mode and made a high-profile announcement that it was taking on progressive MS by targeting regulatory T cells. Now, regulatory T cells, also called TREGs, are white blood cells that play a key role in regulating our immune system. They regulate or control our immune response to keep it from overreacting to unwelcome invaders that cause an immune response in our body. In episode 205 of RealTalk MS, I talked about Abada's plans with the president and CEO of Abada Therapeutics, Samantha Singer, and Dr. Richard Ransohoff, one of the company's co-founders as well as its chief medical officer. Dr. Ransohoff spent 30 years at the Cleveland Clinic, where he founded and directed the Neuroinflammation Research Center in the Lerner Research Institute. And in 2012, Dr. Ransohoff was a recipient of the National MS Society's John Distel Prize for Multiple Sclerosis Research for his pioneering work in MS that led to new insights on immune activity in the brain and spinal cord. Well, Abada Therapeutics is back in the news as they've chosen their first treatment candidate, the T-cell therapy ABA-101, that's designed to treat progressive MS in certain people, and I'll get to who those people are in just a moment. ABA-101 involves harvesting regulatory T cells from an individual and modifying them to focus their attention on myelin fragments. Then the modified cells are infused back into that same individual. But now, when those modified T cells sense damaged myelin, they do the job that they've always done, producing an anti-inflammatory response specifically at the site where demyelination is occurring, reducing the inflammation that drives MS. ABA-101 is being developed for treating progressive MS in people who also have a specific genetic variation that affects their immune function. Abada estimates that this covers about 45,000 people in the United States. Abada is hoping to begin clinical trials for ABA-101 in 2024, We'll continue sharing their progress, and if you happen to miss my conversation with Abata Therapeutics President and CEO Samantha Singer and co-founder and Chief Medical Officer Dr. Richard Ransohoff, you'll find a link to episode 205 of RealTalk MS in today's show notes. Recently published study results from Italy show that autologous hematopoietic stem cell transplantation, or AHSCT, was more effective than using anti-inflammatory treatments and disease-modifying therapies to treat people with active secondary progressive MS. In this study, the research team collected data from the Italian Bone Marrow Transplantation Study Group and the Italian MS Registry. Their analysis included 79 people who received a stem cell transplant after being diagnosed with secondary progressive MS, and 1,975 people with secondary progressive MS who were treated with medications. The research team assessed the level of disability over a 10-year period for each person in the study, and they found that 62% of the people who had received stem cell transplants were free from sustained disability worsening after 5 years, compared to 46% of the people who were treated with anti-inflammatory treatments or disease-modifying therapies. And 34.7% of the people who had received stem cell transplants actually experienced improvement in their level of disability, improvement that was sustained for 3 years, while only 4.6% of the group on medications showed any improvement in their level of disability. Now, after 10 years, the people who had received stem cell transplants continued to show some improvement in disability, while the people who had been treated with medications showed continued disability worsening. These findings need to be confirmed in larger studies, but the outcome of this study not only provides evidence that autologous hematopoietic stem cell transplantation may be a viable treatment for some people who are living with active secondary progressive MS, but it also makes the case that treating the disease with AHSCT may offer significant cost savings compared to having someone remain on high-efficacy disease-modifying therapies for a period of years, and those economics are likely to resonate with insurers. I know that many of you have a real interest in stem cell therapy, so you can be sure that we'll continue to talk about this emerging therapeutic approach to treating MS. Meanwhile, if you'd like to review the details of this study, you'll find a link in today's show notes. Like every episode of RealTalk MS, today's episode features updates and reports about emerging science. And as you listen, some of you may be wondering, when will this science affect me? When will some of these breakthroughs and advances make their way from the laboratory workbench to the clinic? Well, that's exactly what the experts who make up the International Advisory Committee on Clinical Trials in MS are proposing in a new framework that leverages what's been learned over the past couple of decades and redefines how we talk about MS, research MS, diagnose MS, and treat MS. This new framework was proposed in a paper that was published this past November, and in a moment, we'll meet the lead author of that paper, Professor Tanja Kuhlmann. About 8 weeks ago, an international panel of MS experts published a paper calling for a new framework for describing MS, diagnosing MS, and treating MS. Joining me today to talk about what that new framework is and why it's being recommended is the author of that paper, Professor Tanja Kuhlmann. Professor Kuhlmann is an associate professor at the Institute of Neuropathology at University Hospital Münster in Germany and a part-time adjunct professor in the Department of Neurology and Neurosurgery at McGill University. Welcome to the podcast, Professor Kuhlmann.
Yeah, thank you, John, for hosting me. It's a great pleasure to join you for this podcast.
The majority of my listeners are living with MS, and from the moment of their diagnosis, they've become well acquainted with describing multiple sclerosis as relapsing remitting, secondary progressive, or primary progressive. This paper recommends changing that and instead describing MS based upon the specific physiological mechanisms that drive an individual's MS. So I want to begin our conversation by asking you the two questions that I know are on my listeners' minds. First, what does this proposed framework mean? And why is this panel of experts recommending changing something that's been in place for years now?
Yeah, so first it's a framework, and I think it's a first step in a most likely a long journey where we have to reconsider how we actually see MS. And the reason why we think this might be necessary is because we now know that we have the different clinical disease courses or clinical descriptors. However, there are really no big biological difference between these different clinical disease courses. And if you want to treat MS successfully, I think you have to focus on the pathomechanism that is driving the disease. And that's the reason why we think we should reconsider how we see MS. And this is actually what we do in this framework.
When we talk about this new proposed framework, we're talking about sort of redefining MS, or at least discussing it differently in terms of mechanisms, biological, pathophysiological mechanisms that are occurring. Can you talk a little bit about what those mechanisms are and how it might be a little different than the way we sort of see MS today when we talk about it?
So in the past, we frequently describe MS as a disease with two phases. The first disease phase being an inflammatory disease phase, and the secondary disease phase or the later disease phase being more a neurodegenerative disease phase. However, nowadays we know that inflammation persists through the whole disease course, and vice versa. Neurodegeneration starts already very early during the disease course. And you have, on the one hand, inflammation in the brain, and that can be focal inflammation. These are the lesions that you can, for example, see on the MRI. But there's also non-focal inflammation. This is a diffuse inflammation in what we call normal appearing white matter. And this inflammation persists through the disease course. And this is then associated with neurodegenerative damaging mechanisms. Some of them are more dominant at the beginning, some other ones are more dominant later on. And these are the injury mechanisms. And on the other hand, we have repair and compensatory mechanisms that are able to compensate for the injury caused by the inflammation. And these repair mechanism, on the one hand, is something called remyelination. That means the formation of a new myelin sheath after a demyelinating event. And on the other hand, we have something that's called brain plasticity. So the brain is able, so if there's an injury in the brain, to compensate this damage due to this brain plasticity. So other parts of the brain can take over functions in damaged areas. And in the end, you have a balance from these between these injury mechanisms and these compensatory and repair mechanisms, and this decides how your disease at a certain time point develops. So you could imagine, for example, at the beginning when you are younger, you have strong compensatory and repair mechanisms, but these repair and compensatory mechanisms decrease over time and with age, and that then results in disease progression, for example.
Well, that sort of brings me to my next question. You just mentioned how some of these compensatory mechanisms fade as we age. The subject of age is one that's becoming more and more pronounced in terms of MS research. I'm wondering how this framework incorporates the concept of aging with MS and what that means in terms of some of these mechanisms that you're focusing on.
Yeah, so I think age is very important. So we know that age is a strong predictor of disease progression in MS. And as I guess many of us are aware, when we are getting older, many healing processes in our body are not working that well anymore. It can't, for example, if you have a little wound in the skin, if you're younger, it heals very quickly. If you get older, it may take longer. And the same happens also in the brain. And the reasons for this, let's say, impaired function of the cells. On the one hand, there's a change on the one hand, age affects the immune system. We know, for example, that the microglia cells that are local inflammatory cells in the brain, that they change with age and that they become kind of activated status, for example. And on the other hand, you have these cells in the brain like the oligodendrocytes that makes the myelin sheath, or the neurons. They also show signs of aging, and also their function decreases with age. And we are, I think, only at the beginning to understand really the mechanisms or the molecular mechanism responsible for this decrease in function in the cells in the brain. So also there we are at the beginning, unfortunately.
How might adopting this framework impact things like disease-modifying therapies? For instance, today, DMTs have been approved for relapsing remitting MS or active secondary progressive MS or primary progressive MS. If this framework or something like it is adopted, will all of these approved medications have to be sort of recategorized?
No, as I said, I think it's a first step in a long journey. And of course, if we want to change the way how we see MS, we have to everybody has to be on board, and it will be a long process that we discuss it with all the stakeholders, how we will manage this kind of process. And the idea is that if you consider MS as a disease that is driven by different pathologies, which are maybe different between patients and maybe change over time within a patient. The idea is that we have to identify the pattern mechanism that at this a certain time point is driving the disease in an MS patient, and then to select the treatment that works best to address exactly these pattern mechanisms. So the idea is that we, in the long term, will be able to have a more personalized medicine.
From what you're describing, it sounds as though exactly this new framework could lead to more personalized treatment that's addressing those specific pathophysiological mechanisms that are impacting that person.
Yes, correct. That's the idea. That's exactly the idea.
And right now, a person living with MS goes in for a 6-month or annual check-in with their treating neurologist or MS specialist, and they do things like walk down that hallway in the office to get a time on their 25-foot walk and things along those lines. How might adopting a framework that is more about biological mechanisms change the patient's experience when they see their neurologist in clinic?
Yeah, so the idea is that we will develop a kind of, let's call it toolbox, that allows us to detect these different pattern mechanisms. And this might be a combination of MRI, for example, or other imaging technologies, or, for example, things you can measure in blood or in the CSF. And that with the combining of these different tools, you can say, okay, currently this pattern mechanism is driving your disease, and that's the reason why you will get this or that treatment.
We like to interpret any sort of change as being for the better. This one certainly seems to hold promise along the lines of clinical treatment, how clinical trials are done, how the regulators approve medications, and what those medications are actually going to be targeting in the future. That's how I would describe things. How would you describe the benefits of this proposed framework?
I think the benefit should be in the end that we have a better possibility to treat patients. On the one hand, that we have better diagnostic tools to treat the patients and to provide the patient with the best treatment that this person requires at this moment during his disease course. And on the other hand, this framework should also help it should help researchers to reconsider how they design, for example, their experimental studies or trials. So, for example, as a pathologist, in the past, we tended to, for example, compare the histopathology characteristics from patients with either relapsing remitting MS, secondary progressive MS, or primary progressive MS. And of course, we learn something from doing these studies, but I think we can maybe learn more if we, for example, stratify patients, for example, according to the speed of disease progression. So patient with a rapid disease progression, for example, versus patient with a slow disease progression, and see, okay, what is the difference in pathological mechanisms there, instead of only focusing on these different clinical disease courses, just as to give it one example.
So in many ways, this proposed framework really represents sort of realigning the treatment diagnosis of MS with what science has taught us more recently. It's taking all that new information, all of that emerging information, and leveraging it for the benefit of the patient community.
Yes, correct. Yeah.
Well, this recommended framework represents quite a big leap in how we talk about MS, research MS, diagnose MS, and treat MS. At the beginning of our conversation, you called this paper a first step. Obviously, these things aren't going to happen overnight at all. But what do you see as the next step?
I think this kind of framework is the first step, to intensify the discussion in the community and to think about it. Okay, how do we want to do it in the future? What would be the kind of tools that we need? Can we find common grounds? We have, of course, again, then to think about it. Okay, how do we want to describe then the disease? How do we want to decide at which state of the disease the patient is? What can we do with the regulators that we all have the same language, to put it that way?
Well, Dr. Tanja Kuhlmann, I want to thank you for all you do to improve the lives of people living with MS. And thank you for taking time to help us understand what this new framework represents and how, at the end of the day, it's all about improving the quality of MS care.
Yeah, you're very welcome.
That's going to wrap up this episode of RealTalk MS. RealTalk MS is powered by the National MS Society. And you can share this episode of the podcast by letting your friends or family members know that all they have to do is point their web browser at realtalkms.com/279. You'll find that link in today's show notes, so you can easily copy and paste it right into an email or a text. And if you have a minute, I hope you'll visit the Apple App Store or the Google Play Store and download the free RealTalk MS app for your iOS or Android smartphone or tablet. It's the best way for us to stay connected. The app will automatically download the latest episode of RealTalk MS. You'll be able to access any of our past episodes. You'll be able to save your favorite episodes. And it's a great way for me to share bonus content with you. The app is free, so I hope you'll download it today. I'm John Strum. Thanks for listening. Stay safe and make healthy choices.